Hello guys, uh, just to give you a rundown on what BTC Dev you should do in BTC Dev, just a guide through for you to do in BTC Dev. Okay, so these are the files for BTC Dev. I mean, if you have only one tool, there will be tool 0, two tools, tool 0 and tool 1. That is as normal. So these are all the files. You will have BTC Nash as well, BTC Spoolman. These two you won't have, Tabi Z and Tabi you won't have. BTC Variables, BTC CFG, Docslide CFG, Tool 0 and Tool 1. So these are the files that you can download in BTC Dev. Wait, let me check BTC Dev. So first you go to our GitHub and then you click here and go to BTC Dev. And if you look under Clipper, you can see all these files. There's also bash macros, BTC extras. BTC extras are all the sample macro, print start, print end, and then homing override, I think. So that will be under BTC extras. And yeah, that's it basically. So Natch, Spoolman, Variables, Docslide, and the two tools. So what you're going to do first is, as usual, your BTC file. There's nothing to do here. Everything has been included. So there's no more anything variables or what down here. So all will be under BTC variables. So you can close this and go to BTC variables. This is where you include all your tools. How many tools you have, you include them here. So if you are going to do bash macros, you uncomment this. And if you are going to do Natch, you uncomment this. If you are using Docslide, you uncomment this. If you are not using Docslide, you can just comment this out this way, okay? And also Spoolman. I so far have not used Spoolman yet. I don't know what this thing use. I mean how it works, but I have not used it, so it's also included out. So under BTC variables, you have your travel speed, tool change speed, and the wipe speed over here, down here as usual. But these three won't be used. It's just indicated here at the moment so that you at least can remember your speed, your tool change speed. These are all tool change speed, remember that. So at the moment you can remember this speed. So you put whatever your speed is here. Because all will be set later in the tool section, individual tool section, but this is just at least a guide here so that you don't forget what's your speed. And the Z-hop as well, and BTC temp allow as usual, temperature allowance, include LED. If you have LEDs, you put that through on your toolhead. And this is Spoolman integration, like I mentioned here, BTC Spoolman. If we set it to false because we are not using Spoolman yet. And if you are using Spoolman, you can set to true. I don't know how it works, so I just set it to false. So for tool approach location Z, it must always be 0. No matter you have a flying gantry, no matter you have a fixed gantry, it will always be 0. Only unless you are using linear sling. So it's for bed slingers. So for linear sling, you will have tool approach location Z down here because you need the gantry to move up. As you see in my previous video, you need the gantry to move up to a certain height to pick up the tool. So we have a tool approach location Z. So this is only for linear sling. So as you can see here, only use if you are using a linear sling and a Docslide. If you don't have, it's 0. Must be 0 down here. For this carriage sense switch, okay, this one is a bit confusing, but it's written here, set to true if you are using micro switch for the carriage sense, set to false if you are using carriage mounted probe as a carriage sense. So for those who are used to how Linux works, we use a micro switch for carriage sense. So you set this to true because you are using micro switch for carriage sense. This right now, this is showing my VisiBoard Linux, which is using the micro switch as the carriage sense. If you are not using micro switch as a carriage sense, as in my current Voron 2.4, I'm using Voron tab. So we are using that Voron tab itself as the carriage sense. So I'm going to set to false if I use that. But since this is on my VZ board, like you, most of you guys I know are using that, you set this to true. So set to true if you are using micro switch for carriage sense, and we are using that, so you set this to true. And for sling mode, you put here false because this is not a linear sling, so you just put it to false. The rest are at the bottom here, you don't have to touch anything, just leave it, don't touch anything down here, below here as well. So that's it, can close this up. And next we take a look at your BTC Nash. This is as usual BTC Nash. If you have problem of timer to close for BTC Nash, what you can do is you can try to adjust the delay here from -1 maybe to 1 to 2 or up to 5. If you set it up to 5 and you still have the timer to close doing the BTC Nash, what you can do is, there's an option which was given to me by Iran House. Thanks a lot to Iran House. To use the tool changer plugin, the clipper tool changer plugin, the tool calibrate plugin. So what you need to do is, you, let's say you go to Vistas tool changer. Okay, you go to here, Vistas clipper tool changer, and you need to go to clipper extras, and you can download this tool calibrates.py. This is the Python script, the plugin. So you download this, you add it into your clippy. Okay, your clippy. So let's say we go to WinSCP. Let's say give me a minute. This will be my Orange Pi. Okay, log in. So you add it into your printer data. Orange Pi, your clippy, and then extras. So you add it into here, the tools calibrate. There you can see I have tools calibrate.py down here, because I tested it out the other day. So you add this clipper in, this tool calibrate.in into your clippy, and then what you do next is you have to, I don't think you can see this screen, right? Oh sorry, you can't see that screen just now. Hold on, let me try to add in that screen just now. Display capture. Is the display capture in? Okay, hold on. Display capture, I make this bigger. Wait. Yes. Then this display capture. This is my window capture, not this one. Okay. So if you see my display capture down here, you need to add, you go to that Vistas website, you need to add it into your this tools calibrate.py down here, add into your clippy. This will be under, let's say, hold on. So you go to your clipper folder, clippy and extras. So you add it here. This year I've tested it before. Okay, and then what you need to do, if once you add that, you need to add the macros config from our Discord, which Iran House has shared. But it's inside my messages, private messages down here, direct messages with Iran House. If you want, I can share that with you. You need to add that, which will be under here. This will be the macros, BTC Tabi. So this is the macros. So you need that tool calibrate Python script, the plugin, plus this btc tabi.config for it to work. you can try that also. It apparently work for some people, and some people don't work. I mean don't work as in it still have that timer to close error. But I tried it and I'm still getting the timer to close using the plugin as well. So what I did was I used the camera to get my X and Y nozzle offset, and I use this BTC Z. So this BTC Z, it only do the nozzle probing offsets for Z axis only. So this one most definitely you won't have that timer to close error. So you need some XY calibration done first, and then you just do the BTC Z to get the Z offsets. Okay, so that is for BTC Nash or your nozzle offsets. BTC variable, I've done it. And for the bash macros, wait, let me off back this screen, the display capture. And for the bash macros, you need to include if you are doing bash macros. So if you can see here, bash dock tool, this is for bash and docking and undocking of a single tool. So here you change the number of the tool that you want to. Let's say you already build up T0, you want to bash T0 only, so you put here 0. If you made another tool, let's say tool 1, and you want to just do a draw off and pick up of that tool 1, here you change it to 1 instead, 1 this way, right? So if you don't want, then you change back to 0, or you can leave it. The rest is still the same, no problem at all. So after that, what else we have? Basically, okay, the tool 0 config. So this dock slide. Okay, let's go to dock slide. For dock slide, everything is the same. There's no difference as previous version of dock slide, except there's a flying gantry variables down here. So this is for flying gantry. If you are using flying gantry, you set here to true. If you are not using flying gantry, you can leave it at false. That's it. Motor number also, if you are using only one motor, put 1. Especially Linux Link, we actually combine the two motors into one port, because the motor are small. We are using small motor because it's traveling in a y direction, so that you don't need much torque from the motors, so you can leave it 1. But if you are using 2, you put them to 2 is when you are using 2 port in your MCU. So 2 drivers, right? So you will need to put them 2. So nothing there. And for the tool variables, okay, for tool variables down here, on top here, you don't have to change anything. Now comes this part. This part down here is maybe some of you will find confusing. Okay, so let me explain this. This is a bit important as well. So you have your variable pickup location X. Okay, variable pickup location X, that means where you want the tool to go to when you want to pick up. So this normally will be your, if you are in the old version of BTC Dev, this will be your pickup location Y, or pickup approach location Y and approach location X combined together. So it will become one with the variable pickup approach location. So 17 is the coordinate. First, there are four variable 4 parameters down here. Sorry, there are 4 parameters down here. First one, comma, second one, comma, third one, comma, and the fourth one. So the first one is X. This is X coordinate 17. This is Y coordinate 110. This is Z coordinate -128. -128 means the axis don't move. So the axis stay at where it is. So you put there -128. Only when your axis move, you enter the new axis coordinate. So when we want to do a tool change, our Z axis don't change, right? Don't move at all. So we only goes to X coordinate and Y coordinate. Z axis don't change, so we put there -128. And for this 700 is the speed. So let me close this. As you can see, I put here 700. So your approach excuse me, just now if you remember, your travel speed, tool change travel speed is 700. So I put here 700. This is my travel speed for the approach location. When during print, it goes to its first approach location, that speed, so 700. That can be fast because to me the travel speed, so it doesn't do anything. This is the pickup move. So this is what the the command for what is going to do during pickup. Okay, so as you can see, the first one here is dock slide deploy. After it goes to this approach location, that means once it's ready to tool change, so the first thing to do is to deploy dock slide. So I have a dock slide, so the dock slide will deploy first. That means it will bring down the tools, bring down the docks. So dock slide will deploy first. And then the second thing what it will do is, if you can see here, this line after dock slide deploy, remember that the first one is x coordinate, so -128. That means my x is at 17. My x doesn't change. What change is now my y goes to 8. So from 110 at the approach location, now it goes to 8 because my pickup for the tool is at y8. My x is 17. So here x is 17. If you are really too confused, you can do here 17 as well. That means your x still stay at 17, but your y change from 110 to 8. You can put here 17 as well if you want. But for us, I mean for those who do this kind of programming or coding, I don't know what it is. It's not me, I'm not the one who do it, but those who prefer or clipper ways, how they do it is they put -128 so that it doesn't change the axis. There's no changes in the coordinate for the axis. So x, if you from 17, the next step you want to go here, you still stay at x17, you just put there -128. So if you can visualize, okay, now my gantry and my docks are all in front. So remember that now 110, we take that as 110 my y. Remember that my gantry is in front. So take note, if your gantry is at the back, these two coordinates will change, don't know how much, where your position is. So for x, I know when after you approach location, when you want to make the move going forward, right? Let's say your gantry is at the back, so you want to go forward first. The first move for the tool change, you want it to go forward, so your x doesn't change. So you put here -128. Your y change. So let's say your y from 110 now becomes maybe 230 because your docks is at the back. Mine is 8 because my docks is at the front. So from that position is going to the front, it will be at 8. These are absolute. So how you know the coordinate is much easier. You just look at your Clipper UI, this one right here, this one, you just look at this coordinate down here. So you move your tool head up to where the y location is, and then you key in the coordinate that is given down here, maybe x17, y 200, z. I know it doesn't change because we don't do any movement in z. So you just key it in down here, the coordinates. So this will be your x, this will be your y, this will be your z. As you can see here, my z totally doesn't change at all in all the movement. Z -128, -128, -128, because there's no changes in z during tool change. So all are -128. But for my x, here 17, here -128. That means my x doesn't change. So another example is you can put here 17. Okay. So -128 down here, and now it goes to y8. So that means from the 110y it goes to y8. Z doesn't change, but the speed I change it to 400. So this is the speed now, 400, because as you can see under variables, my tool change speed is 400, right? So let's check again, tool 0, and then after it move forward in y, it need to move left, or for your case, if you have tools at the back, you need to move to the right 10, right? So just now from here is 17, let's say 17, move right 10. So here you will put 27 because you have moved X in 10, right? But for my case, sorry, I put my X 28 because I want it to move extra 1 mm just to safety measures. I have the space, so I move it 28, just 1 extra. So if you can see here, 17 X has moved to 28 X, he has moved 11. So you put here 28, right? From here, okay, let's say here just now from 17 here, then here no change, that means your X still at 17. Now you move your tool head to the right 10, and then you get the coordinates, so it will be minus 28 down here. Sorry, you need to move to the left, right? For you to pick up, this is pick up, so for pick up you need to move to the left if your tool head is at the back, if your dogs is at the back. So that means if your coordinates here is 17, the first move it doesn't change in X. The second move here should be 7. So your move should be 7 to move 10 to the left in X. And then your Y of course doesn't change, it stays at minus 128. Your Z doesn't change, and the speed is down here. So yours should be like that, should have like that. So for me, in my case, mine is this way, 28 here, Y doesn't change. This is a 10 movement. Mine is 11, so from 17 to 28 is 11. So take note. So mine will move 10 to the right to pick up. Yours will move 10 to the left to pick up. M400, we give a pause here normally. This is not a pause, sorry. M400 is, it will wait for everything to finish doing all the movement before it proceeds. Then the next is wipe nozzle direction -1, because sorry, under BTC variables, is it? I think you already changed, so never mind. So for wipe nozzle direction -1, because my tools is in the front. This is the macros under BTC. Let me check. Is it under BTC? There, wipe nozzle. So wipe nozzle, you don't need to change anything. You can change the coordinates here if you want, how you want it to proceed to wipe the nozzle. If you know about this wipe nozzle macro, you can change here. But the direction itself, you don't need to change this direction, because it will calculate automatically. It knows that if you have the tools at the back, the wipe direction is different. If you have the tools at the front, the wipe direction is different. So it will do it automatically in the macros. So you don't have to change anything. If you want it to wipe after pickup, we normally do a nozzle wipe. And then here is the last step that you will go back to its approach location. That means just now here it's 17, 110, 128, right? Exact number change. So just now approach is at 17, 110. So because this has gone to 28, now we need it to move back to that approach location Y. So minus 128 stays the same, because here is 28. So minus 128 stays the same, the axis don't change, but the Y now goes back to 110. So it goes back to the approach location back, and then the dog slide will park. So that is the explanation for how you key in the move. You can do a lot of things here. Let's say if you want to adjust, you want to add another move before or after, then that, all these things, you can just create another line here. Sorry, you can just create another line here. This one you copy, and then you paste the same thing, and then you can put, let's say you created a macro for it to do some things that you want to maybe move the place somewhere to clear the umbilical. You create a macro for that. You can put your macro on here, so it will also from here to here do your macro, then it will pause, do the wipe nozzle, so whatever things. So this is much more powerful, because all the pickup move you decide how you want to move. This is the basic, our normal pickup move. But if you are using, let's say for example, stealth changer, the pickup move is different. They have some Z movement, some drop the Z, up the Z movement, something like that. So you can add whatever movement you want. And another thing, that this thing can do is, like that day Fun Days asked me about can the macros for BTC pick up for the left tool move to the left, for the right tool move to the right. So you can set it, so you want T0 to move to the left during pickup, you just change the coordinates here. Whatever coordinates you want, just change them here. If you want the right tool to pick up to the right, then you change the coordinates of T1 the other way around. So it's very easy. Draw off location is also the same example. For here, variable offset, if you still don't know, not sure about this, you can just PM me or ask me in Discord. I will be glad to explain as well. For these are the nozzle offset. So for tool 0, offsets are all 0. So this is nozzle offset. As usual, tool 0 is 0, that's your master tool. And then the rest of the tool will have the offsets to this tool. This is the input shaper for tool 0. And this one you don't need to change. Here you need to put no need to put because it's already, the sample is in there. So Carishan T0, all these are here, and the extruders are all here. LEDs, now we don't use this Julian's chill clipper plugin for LEDs. So we put the individual LED in the individual tool config file. So all the LEDs are here. Your fan, this is probe. So because I'm using Voron tab for my Hive, I have the probe section inside the tool as well, because every tool can probe using the Voron tab. So I have tools in all the probe section. I have probe in all the tool section as well. So here is your temperature sensor, resonance sensor, that's all, that's it. So let's close this. And if you tool 1 is the same thing, your tool 1 you just change the no need to change the sample, all there as well. You just change the coordinate how you want it to move. The X position down here, your Y position. I think most probably your Y will always stay the same between the two if your Y don't change. Sometimes your tool 1 you need to go maybe 1 mm further in Y because of maybe some tolerance issues or some difference in your tool head or whatever thing that you do, that you need the Y to be a bit different. You can also change the Y exactly to where that particular coordinate is. So you can put the Y the same here. So it's up to you. So this is a very powerful tool. So as you can see here that my draw off move, my Y has changed to 7 here, but my pickup is at 8. The Y, you can see, you can set different as well. We don't have a single pickup approach location Y. You can set whatever coordinates you want. So it's a very, very, very powerful macros. So I want my draw off to be further in the tool, to be further in the dock, so that it can the host align properly. Okay, so I put my Y at 7, but when pick up, I don't want it to go too much in. So my Y is at 8. So you can see the two difference here. You can set them individually. And this is the offset as well. This is my tool offsets, the nozzle offsets, and the rest are all the same. No difference down here. So for your case, this probe section down here for tool 1 or whatever other tools you probe here, you must comment them out. Okay, you have to comment this probe section out. You cannot have this probe section. Probe, you only need one section, which is in your tool 0 or in your printer.cfg, but the rest of the tool don't have this probe section. So you have to comment this out if it's not comment out, unless you are using Voron tab, like for my 2.4. If I'm using Voron tab, all my tool have probe, but this one I have yet to finish with the testing. This one so far we have yet to test to finalize this. Okay, so the rest all stay the same. That's it. There's no more other changes. So basically that's it, the simple thing for you to test this BTC clipper. If you have any question, just just ask me in Discord, confirm with me or ask question, don't worry. We also want to integrate Eden House has had a lot during this period in adding some fail safe to the macros, recovery to the macros, and LED. All this I have yet to test, but thanks a lot to Eden House. And once I fully tested them and everything is working as should, I will integrate them into BTC Dev as well, and then we will update you on this. Alright, so thank you for listening and hope you understand everything. Hopefully this video has been a great help for you. Okay, see you guys.